Question 4C. Graham has a large number of packs of cards and wants to sell some to Andre. Graham claims the packs he has to sell are, on average, heavier than 28.3. Graham draws a histogram of the masses of his packs of cards, as shown below. Andre randomly selects 10 packs from Graham to test Graham's claim. He finds that the total mass is 285. Okay. Question I. What feature of the histogram supports conducting a significance test on the sample mean using Andre's data? All you've got to say here is the histogram shape looks like a normal distribution. Okay, that's it. Just one mark. It's shaped like a normal distribution. It's got the peak in the centre. It's roughly symmetrical. If you want to go into more information. Okay. You can say it resembles a bell-shaped curve. If you just said symmetrical on its own, that wouldn't be necessarily a normal distribution. But if you said a peak in the centre, symmetrical tails on either side. But basically, as long as you just say it looks like a normal distribution, that's fine. Part 2. Given the population standard deviation of the masses of Graham's packs is 0.32 grams, test Graham's claim. Okay, there's our hypothesis test for the mean. So we start with H0 and H1. And this time we're testing the mean of the normal distribution, which is the symbol mu. So don't write rho. Okay, that's the PMCC test. This is mu. And Graham is saying his cards are on average heavier than 28.3, but that is what we're going to use as our mu. Okay, 28.3. We're going to always have H0 is that the mean is equal to something, and then Graham's claim is that the mean is greater than this value. Okay, so you don't have an option of a sign choice on H0, it's always equals. Okay, and then on H1 you look in the wording of the question. Okay, if it just says heavier or lighter, you've got that indication of the direction. If not, it could be a not equal to sign. Okay, Andre has chosen 10 packs and the average of the sample, all you need to do is just divide by the 10, and that's 28.5. So that just gave you one little job to do there, but that's easy enough. The distribution of X bar, which is the mean of the sample, that is going to be normally distributed with the same original mu centered at 28.3. And then you have this alteration of the standard deviation to remember. Okay, 0.32, excuse my son's trombone playing next door, 0.32 over square root n, which is 10. He doesn't know I'm recording videos, so we might hear some weird noises next door. So X bar is normally distributed 28.3, 0.32 over root 10. So the old standard deviation divided by square root n, that's going to be our new standard deviation. So we've got on our picture a normal distribution, 28.3 there, 28.5 there on the top, slightly higher up, and then we've got that shaded area. We want to work out how big that shaded area is. What's the probability that we get 28.5 or more? It's quite distracting, sorry. Try and concentrate on me and I'll try and concentrate on what I'm talking about. Okay, yeah, let's just put this into the question and finish this one off. So NCD, We want 28.5 up to big positive. We want to put in 0.32 divided by square root 10. And we want to put in 28.3 as the original mean. And we can work out that the probability of that outcome is 0.02405. Now, it's not a two-tail test, so we don't need to multiply that by 2. This tells us that there is about a 2.4% chance of this outcome happening whilst the original mean is still 28.3. Okay, which is a pretty small probability. We're comparing it to a 3% level, which is unusual, but there we are. And that's going to be below our level. And when it's below, then we're going to say that's low enough for us to reject H0. We're going to reject H0 and conclude there is enough evidence. Now we're Graham's claiming that his packs are heavier than 28.3, which is what we're changing our mind to. So we can say there's enough evidence to support Graham's claim, because he was claiming that the weights were more than 28.3 on average. Okay, so make sure you're saying in context what the conclusion is. Enough evidence to support Graham's claim that his packs are, on average, heavier than 28.3 grams. Okay. You can also do that with the critical region method, where you work out the critical region for 3% and then see where the 28.5 falls into that. So if you wanted to do it that way, I won't write that down, but you'd use your inverse normal. Now 3% at the top end, you'd put in 0.97 as the area below, and you'd work out your critical value is 28.49. So anything above that would be in the critical region, and 28.5 is just in there. So again, you'd end up rejecting H0 if you fell into the critical region. Okay, so that's another way of doing it. Both ways are equally valid. Make sure you put your conclusion in context.